Morning, Happy New Year. How's everybody doing?
Yeah.
Happy to be here. Okay, so we're gonna start right in. Yeah, question. Pencil?
Yeah. That was the last one.
I don't have any. I loaned them to you guys.
Nice.
Sorry.
Just ask as you're closing.
Okay, so we're starting right in with a new unit today. So today we're going to talk about mid-segments of triangles. Okay, so first the definition. A mid-segment of a triangle is a line segment connecting midpoints of two sides. Line segment connecting the midpoints of two sides. Okay, so if you have a triangle like this, and you have the midpoint of one side like this, and then a midpoint of a second side, this, then the mid segment would be the segment that just connects those two midpoints. Okay, so there's a few important properties having to do with the mid-segment of a triangle. So here they are. Here's some facts. The first obvious fact is any triangle has 3 mid-segments. Right? Any triangle has 3 mid-segments. So if I draw this, it's really obvious. If I have a triangle like this, there's 3 midpoints, right? One midpoint of each side. There's this midpoint, and this midpoint. And so the 3 mid-segments here would just be like that one, and that one. Another important fact then is that when all 3 mid-segments are drawn, it splits the triangle up into 4 triangles that are all congruent to each other. Okay? And all 3 mid-segments are drawn. Splits the triangle up into 4 congruent smaller triangles. Another important fact about mid-segments is a mid-segment is always parallel to the opposite side, to the third side. Mid-segment is always parallel to the third side. Okay, so if I have a triangle and a midsegment drawn, like for example, from here to here. This midsegment is parallel to the third side over here. Looks like it should be true, doesn't it? It's definitely true. And the fourth and final fact about midsegments is that a midsegment is always half the length of the third side. Always 1/2 the length. Of the third side. So problems that involve a midsegment usually involve one of these last two facts. Either the fact that a midsegment is half the length of the third side, or the fact that a midsegment is always parallel to the third side. Let me give you some examples. So like, for example, they might give you a triangle with a midsegment drawn, and they have to either tell you it's a midsegment or indicate by markings that it's a midsegment. You can't assume just by the picture that it's a midsegment unless they give you appropriate markings. So there you can assume it's a midsegment. But if it just kind of looks like a line segment that's drawn in the middle, that's not a midsegment unless they tell you it is. Okay, so an easy type of problem would be, they might say this has a length of 18, find the length of this segment. So that would be really easy. It uses the last fact. A midsegment is half the length of the third side. So if this is 18, this segment has to be twice as long as that, right? So this would be easy, x equals 36. Pretty easy, right? But they can get a little bit harder. They might involve algebra. Like, for example, suppose I have a problem like this, and a midsegment drawn. That. And let's suppose they gave us some algebra expressions like, suppose this is 4, and this segment is 5x minus 2. It's not that much harder, right? What would you do? How could you find it? Say it again?
4 multiplied by 2 equals 5x.
Yeah, so if this is 4, this has to be 8, so you just say 8 equals 5x minus 2. So that's pretty easy, right? So you say 10 equals 5x, and x is 2. Okay? The algebra might get a little harder, but it would still be just a linear equation. So like, for example, suppose I have a midsegment like this. Okay. And let's say this time we have, this segment is 9x minus 59. And this segment is 34 minus x. Be careful, I don't want you to get sucked in there. Kind of half kidding. All right, what else? How can you solve for x? I know the same thing, right? What do you do?
Multiply 9x minus 9.
Yeah, so 9x minus 59 times 2 has to equal 34 minus x. Yeah, it's exactly the same thing, right? The algebra is just a little bit more involved, but it's not too bad. Another thing you could do is you could say, this segment, 9x minus 59 equals half of 34 minus x, but then you have fractions involved, and I think the algebra is a little harder when you have fractions involved, so this is an easier way to handle the same situation. So this just needs to be distributed, so you go 18x minus 2 times 59 is 118 equals 34 minus x. So then get all the x's on one side. This would be 19x. And add 118 to both sides. It would be 152. Okay. And then divide by 19. So I can't do that. So 152 divided by 19 is 8. So x equals 8. So the algebra was slightly more involved, but it's not that much worse, right? Let's try another type of problem. Suppose you have mid-segment. This got really hot in here all of a sudden, right?
Yeah.
Whew. So suppose you had this. Huh?
Here.
Switch here.
Oh, not. And it's gonna explode.
Opening?
Something's opening?
Yes. Switching to open. Nice. Like that?
Oh,
And you're in the blast phase.
you'll be all right.
Maybe.
All right.
And the blast phase.
So suppose you have this problem, and this time, let's say they tell you that this is, this angle is 60, and this angle is 45, and we're trying to find the measure of this angle right here. What do angles have to do with this? I didn't give you any facts that had to do with angles, did I? No. Maybe. Well, what did the facts have to do with? Parallel, right. Whenever you have parallel lines, which we have here, we know something about angles, right? We know that alternate interior angles are congruent. We know alternate exterior angles are congruent. We know corresponding angles are congruent. We know same-side interior angles are supplementary, and we know same-side exterior angles are supplementary. So we have pairs of angles here where we know the relationship. In particular, if this is 60, this is 60, because these are corresponding angles. Now we can use the upper triangle. We know 2 out of the 3 angles. We can find the missing angle. Does that make sense?
Yeah.
We got this triangle right here. We can say 45 plus 60 plus x equals 180. So 105 plus x equals 180, and x would have to be 75. Okay, let's just do one more. Suppose we have a triangle, mid-segment, like that. And what if they told us this angle up here is 106 minus 5x? And this angle down here, which we know is congruent to it, is 7x minus 14. So this is another of the same type of thing. You just set them equal to each other, right? These are corresponding angles. They have to be congruent. Now, if they gave us this angle down here in the bottom and then this angle right here, what would have to be the relationship between this bottom angle and this angle, this blue angle? They'd have to be supplementary because those would be same side interior angles, right? So depending on which information they give you, you either set them equal or you set them equal to 180, add them up. right? So this would be 106 minus 5x equals 7x minus 14. And that's it. If I solve this, I can move the x's over to the right, plus 5x. So I get 106 equals 12x minus 14. And then add 14 to both sides, I get 120 equals 12x, so x would have to be 10 then. Does this all make sense? So two facts you need to remember. The midsegment is half the length of the third side, and the midsegment is parallel to the third side. The other two facts that I gave are a lot more obvious, right? You get 4 congruent triangles out of the midsegments, and you get, and there's 3 midsegments in a triangle. It's kind of obvious too. Any questions? All right, so the homework's on Delta Math. It's just called midsegments of triangles. Okay.